Hello class, Dr. Barnes here, your favorite lecturer. Please, let's take a look at these questions. We're supposed to find their Fourier transforms, okay? These are some signals, okay? So now the Fourier transform for the first signal, which is of this particular format, okay? So here is t, and here is x of what? T. And here is t, and here is 0, and here is 1. Okay, so we're supposed to find the Fourier transform of x of what? T is equals to this one, okay, here minus infinity to what? Infinity. X of what? T into e minus what? St d what? dt. So this is what we're supposed to find, okay. But here we can say that it's actually equals to 0 to what? Infinity. X of t is x of t is going to be what? 1. So 1 times this guy is going to be this guy. So I'll just write minus what? Minus dt here. Okay, so here is 0 to t. Sorry, it's not 0 to infinity. I'm so sorry. It's 0 to t. Because you can see that 0 to what? T. Okay, so here, this is what I'm going to have, okay, into what? Into the t. Okay, so this is what I'm saying my function is. Okay, let me rewrite it again for you. 0 to what? T. Okay, e minus what? St d what? dt. Okay, so it's this simple. So now what we can do here is that we can just integrate this particular function that we have. So if we do that, I'm going to get 1 minus what? 1 minus 1 on s, minus 1 on s, okay, into what? E minus what? St. Okay, e minus st. Okay, so that's what I'm going to get. Okay, and here I'm going to have what? 0, and I'm going to have t. So this is actually equals to what? Minus 1 on what? S. Okay, into e exponent minus what? St minus e exponent what? 0. Okay. So now if I have that one, then this 1 times, okay, wait a minute. Let me simplify it further. I'll have minus 1 over what? S into what? E exponent minus what? St. Okay. Minus what? 1. Okay. Which is actually equals to 1 over what? S into what? If I multiply this by this, I'll get positive. So I'll have what? Positive 1. If I multiply this by this, I'll get negative. So negative e minus what? St. Okay. So now the Laplace transform of x of what? T with respect to this function is going to be what? 1 over s into what? 1 minus what? E minus what? St. Okay. So that's the first particular signal. That's its Laplace transform. Okay. So now let's go to the second one. Okay. So the second one is such that we have what? II, and II is going to be here. Okay. Okay, here is t, and here is what? T1, here is T2, and here is what? X of what? T, and here is what? 1. Okay. So now if we have this one, then the Laplace transform of x of what? T is going to be equals to minus infinity to what? Infinity x of what? T into e, okay, into e minus what? St, okay, minus st, all right, minus st dt. Okay, so I'll just write dt over here. Okay, so now if I write dt over there, then going forward, what I can do is I can have here to be equals to, if I introduce the limits, which is occurring from t1 to t2, then I'm going to have here t1, here t2. Okay, so here is 1. So if I put 1 here, 1 times this one, it will be this one. So I'll just have minus what? St dt. Okay, so now if I should integrate this guy, I'll get minus 1 over what? S into what? E minus what? St. And here is what? T1, here is what? T2. Alright, so that's what I get. So now if I should move further, what I'm going to get here is going to be like this. So here I'm going to get introducing my limits into the function. Okay, if I should introduce the limits into the function right now, I'm going to have minus 1 over what? S into what? E minus S T2, okay, and then minus E minus what? S what? T1, okay. So if I multiply this by this, I'll get positive. This by this, I'll get negative. So I'll have 1 over what? S into what? E. This by this, I'll get positive. So E minus what? S T1, okay. This by this, I'll get negative. So minus E minus S T what? 2. Okay, so now the Laplace transform of x of what? T in this case is going to be what? 1 over what? S into what? E minus S T1 minus E, okay, minus S T2. Okay, I think I didn't write it well. Let me write it well. So here, I'm going to have Laplace transform of x of what? T. Okay, it's going to be what? 1 over what? S into what? E minus S T1, okay, minus E minus S T2. Alright, so that will be the solution to this particular one. So let's move on to the other two, okay, in this particular series. Okay, so now we're going to have our third function, okay. So the third function is what? I. Okay, so what is I? Okay, so I is a function like this. X of what? T. Okay, and here is what? A. And here is 0. And here is what? Going to be what? T. And here is what? T. So Laplace transform of x of what? T, which is equals to, which will be equals to infinity minus what? Infinity. X of what? T into E minus what? ST. Okay, minus ST d what? dt. Okay, so if I do this one, then I'm going to have Laplace transform of 0 to t, 0 to t, and then here you see 0 to t into what? X of what? T into E minus ST d what? dt. One thing is that with this particular function, this one is a slope, so I must find the equation of this particular line. Okay, so to find the equation of this particular line, I'll use what? Points. What are the points I'm going to use? Here, this point is what? 0, 0. So 0, 0. And this point here is what? TA. So, and what? T, what? A. So now, if I use this point, then my slope here is going to be what? A minus what? 0 over what? T minus what? 0. Changing x over changing y. Y2 minus y1 over what? X2 minus x1. So now if I have this one, then I'm going to have slope of what? A on t. Okay, and what is going to be the equation of my line? The equation of my line is going to be what? X of what? T minus the y component of the first point, which is 0. And then it's equals to my slope, which is A over t, into what? T minus the x component of the first point, which is also 0. Okay, so like this. So I'm going to have what? A on what? A on big T on what? T. Okay. Now, I just have to just go straight ahead and put this one into the equation. So now what I have is that x of what? T is equals to what? A on what? T into what? T. Okay, so that's my x of t now. So now my equation now, my Laplace transform. Okay, so my Laplace transform, okay, of x, okay, of x of what? T is now equals to here 0 to what? T, because my signal is occurring from what? 0 to t. Okay, so now if I have that one, then I'm going to have A on what? T into E minus what? ST d what? dt, which is equals to what? A on what? T into what? 0 to t into what? T into E minus ST d what? dt. Okay, so this is integration by part. Okay, I can say this place is U and this place is V, and I'll use what? Integration by part. So here, integration by can know that one from our previous lectures, especially Fourier series, integration by parts, or also called the UV rule. Okay, also called the UV rule. Okay, so now if you know this one, then we can just straight ahead go ahead. So if I should do my integration by part, then this is what I'm actually going to have. Okay, I'm going to have A on what? T into, I'll hold T, differentiate E minus ST over what? Over S, okay? Over minus S, over minus what? S, okay? And then here I'm going to have minus E minus what? ST. I'm integrating this guy 2 times, so I'll have what? Over what? Minus S what? Squared, okay? Over minus S squared, so it will be like this, okay? So now here I'll just close it. Here is 0, here is T. I'll introduce my limit. So if I introduce my limit, I'll have A on what? T into what? Into minus, this minus will affect here. Okay, so minus T into what? E minus S what? ST. Okay, E minus ST. Okay, over what? Over S. Over S. Okay, then I'm going to have minus. Okay, this minus is going to come here. So it's going to be what? Minus. Minus what? Minus E. Okay, minus here. How can I even write it? Okay, let me just write something like this. Okay, so alright, so minus E. Okay, minus what? ST. Minus ST over what? Over minus S squared is what? S squared. Okay, and then yeah, so that will be all for what? For T. Now I'll come to the lower limit, 0. So if I put 0 here, if 0 comes here, this whole function becomes 0. But if 0 comes here, E exponent 0 is what? 1. So 1 and minus S squared is what? S squared. So 1 over S squared, which will be what? Which will be affected by this negative. But you must remember that this is from the lower limit. The lower limit, which is 0. The lower limit already has a negative sign. So negative will make this guy positive. So now I have 1 over what? Plus 1 over what? S squared. Okay, this is what I'm going to actually have. And then I can close my bracket. Okay, so now if I have this one, then if I should simplify further, then I can have A on what? If I should bring S squared out, S squared and then T. Okay, S squared T. Okay, then this guy times this guy, it will be what? It will be positive. So I'll have what? 1. Okay, so S squared has come out already. Alright, and then I'm going to have minus E. Okay, minus what? ST. Alright. Okay, that is from this one. Okay, because S squared has come out and it's negative, so this guy plus this times this guy will be what? Negative. Okay, minus what? Here T is here, so T. So now here, because it's not S squared, it's S, so that means that S must be here. E minus what? ST. Okay, so basically this is what I'm going to what? Have, and this is the what? This is the full, this is the Laplace what? Transform. Okay, so this is the Laplace transform. Okay, so this is the Laplace what? Transform of x of what? T. If you don't want that, you can say x of what? S. Okay, so that question, this ends that question. Now, our last question in this lecture is going to be IV, okay, which is particularly this function, okay, this function. Okay, so here x of what? T, and here is what? A, and then here is what? T, and then here is what? T on 2. Okay, here is what? 0. Okay, so this particular function. Okay, so this particular function. So now in this function, what we can say is that x of what? T is actually equal to sine what? This is a sinusoidal function. Okay, sinusoidal function is what? Sine omega naught what? T. Sine omega naught what? T. So this is that particular function. So now I'm going to have here, I'm going to have, let's say, minus infinity to what? Infinity into x of what? T into what? E minus what? ST dt, which is going to be what? The Laplace what? Transform. The Laplace transform of what? The Laplace transform of this particular function, which is x of what? X of t. Okay. So now the Laplace transform of x of t, which is what, sine omega naught t, sine what, omega naught what, t, okay, is going to be sine omega naught t, okay. Here is going to be here 0 is from 0 to what, t on 2, so 0 to what, t on 2 into what, into sine what, omega naught what, t e minus what, st d what, dt. Okay, so this is what it's going to actually be like. Okay, but one thing is that whenever I can also rewrite this one in this way, so 0 t on what, 2 into what, e minus what, st, okay, sine omega naught t d what, dt. I can also write it in this way. So now whenever you have a function as what, integral ax, you have integral ax into what, let's say sine what, sine bx, okay, d what, dx, okay, which is actually in this particular format, okay, which is actually equals to what we have here, because you can see that this one is in this same format as we have here, because here we have what, e exponent minus s what, st, okay, into what, sine what, omega naught what, t d what, dt. It's, I mean, they are virtually what, the same. They are virtually the same. So now if we have this one, then what happens is that whenever you have eax into what, sine what, bx d what, dx, okay, integral, okay, integral, okay, then is equals to, then the integral of this one, okay, is going to be equals to this one is going to be equals to what, eax, okay, over what, a squared plus what, b squared, okay, into what, into a sine what, bx, okay, a sine bx minus b, okay, b cos bx, okay, b cos what, bx, okay. So now here in this question, if we should note the value for what, our a, then our a is equals to what, minus s. If we should know the value for our b, okay, our b is equals to what, omega naught. But omega naught, what's the formula for omega naught? Omega naught is always equals to what, 2 pi on what, t. Okay, omega naught is equals to what, 2 pi on t. So these are the values that I'm going to use to actually solve this particular question. Okay. Okay, so now to proceed further to solve this question, what we're going to do is that I'm going to have it to be equals to this. So now the integral of what, e minus what, st into what, sine omega naught, okay, but I told you that omega naught is what, 2 pi on t. I just told you that. So here 2 pi on what, t, okay, into what, t. Okay, so this one, okay, if I'm going to actually expand this, then I'm going to have, this is what I'm going to actually have. I'm going to have EAX, okay, so EAX is here, E minus T, okay, over what, A squared. A squared is what, S minus S squared. Minus S squared is what, S squared, okay, plus what, B. And what is B? B is what, 4 pi on what, T, okay, but it's B squared. So B squared means, sorry, into what, B squared. B squared is what, 2 pi on T, but it's what, B squared, so 2 pi on T squared. 2 pi on T squared will give me what, 4 pi squared on T what, squared, okay. This is what it will give me into what, into A sine bx, okay. So A sine bx, so what is going to be that A sine bx? Okay, so I know that A is minus s, so minus s, okay, sine what, sine bx. And what is bx? Bx is actually what, 4 pi on 2, 4 pi on t, okay, into what, into t, okay. So I'll get what, sorry, is bx, and b is what, 2 pi on t, so I'll get here what, 2 pi on what, t is bx, so the t here is what, the x here is what? T. Okay, minus cos b, okay, minus cos b, and I know that b is what? 2 pi on t. So I'll write here 2 pi on what? T. Okay, 2 pi on t into what? Cos what? Bx. And what is bx? Bx is what? 2 pi on t into t. So it's what? 2 pi on what? T into what? T. Then I'll close it. So basically, this is what I actually get in this particular question. Okay. So now what I can do is that I can just simplify. I can just put it into the original equation and then simplify. So now putting this one into the original equation, then I'll get the Laplace transform x of what? S to be equals to, here I had a already. So here I will have what? E minus what? St. Okay, e minus what? St. Okay, e minus what? St over what? Over s squared plus 4 pi squared into what? T squared. Okay, into what? Minus s sine what? Sine 2 pi on what? On t. 2 pi on t into t. Okay, minus 2 pi on what? T into what? Cos what? Cos 2 pi on what? T into what? Into t. Okay, then you close it like this. Okay, and what are my limits in this particular function? Okay, my limits here are 0 to what? To t on 2. T on what? 2. Okay, so those will be my limits, and this will be my expansion. Okay, so now if I should introduce in my limits and then do my substitution, okay, then that means that you introduce the upper limit first. Okay, so then that means that x of what? S, the Laplace transform is what? A into what? E minus what? S t on what? 2. Okay, st on 2. Okay, over s squared plus 4 pi t squared. 4 pi t squared. Okay, 4 pi t squared into minus s sine. Okay, sine 2 pi over t. And then here I'm going to have what? I'm going to have t on 2. Okay, t on 2. Okay, so now if I should have t on 2 here, then what it's going to mean is that t, okay, on what? On 2. Okay, then what is going to actually mean, minus s sine, we have here 2 pi on t, okay, into what? T on what? 2. Okay, minus 2 pi on what? T. Okay, cos 2 pi on what? T into what? T on 2. Okay, t on 2. All right. So this will be for the upper limits. Okay, this will be for the upper limits. Okay, so let me just write it this way. This will be for the upper limit minus. Okay, so here let me bring this one. Okay, let me bring this one. Okay, minus the lower limit. Okay, so minus the lower limit. The lower limit is 0. Okay, so basically I'll have e exponent minus e exponent 0. Okay, I'll have e exponent 0 over s squared plus 4 pi t squared. Okay, into what? Minus s sine 2 pi over what? T into what? 0 minus 2 pi. Sorry, this is what? 2 pi. Sorry, this is 2 pi. Okay, minus 2 pi. Minus 2 pi on what? T cos cos 2 pi on what? T. Here is what? 0. Okay, then I can just close here, and then I can just close this one this way. Okay, I can close this one this way. So basically, this is what we're going to have. Okay, this is what you're going to have. My marker has become very faint. I just don't know why. Okay, it has become very faint. I just wish I could deepen it a little bit more for you. Okay, my markers are faint. I have to get new markers. Okay, but please try and then know from how I explained it. Okay, so now here, what is going to happen is that here, t will cancel t, 2 will cancel what? 2. What is sine pi? Sine pi is 0. Okay, you should know that sine pi is what? Sine pi is 0, because if you draw your sinusoidal curve, okay, so it's going this way. Okay, so here is what? 0. Here is what? Pi. Sine pi is what? 0. Here is what? Pi on 2. Pi on 2 is what? 1. Sine pi is what? 0. So now here, so sine pi is what? 0. So if sine pi is actually 0, that means that the whole of this place will become what? 0. Now let's see here. T will cancel t, 2 will cancel 2. Okay, what is cos pi? Okay, cos pi, let's draw our cosine curve. Okay, if we draw our cosine wave, it's going to, it's like this. Okay, it's like this. Okay, so here is what? 0. Here is what? 1. Here is what? Minus what? 1. Here is what? Here is 0. Here is what? Pi on what? 2. Here is what? Pi. So cos pi is what? Minus 1. Cos pi is minus 1. Okay, so now that means that here becomes what? Minus what? 1. Okay, so minus into minus, it will become what? Positive. Okay, positive. Okay, so now that one into this one. Okay, so basically here I'm supposed to actually close here with this one. Okay, so that means that here I'll have what? I'll have negative what? 1. Negative times negative, it will be what? Positive. Times 2 pi on what? T. And then this one. Okay, so that means that what I'm going to have there is actually going to be like this. Okay, so that means that I'm going to have x of s is equals to a, okay, into here, into here. I'm going to have e, okay, I'm going to have e exponent minus s t on what? 2, okay, over what? S squared plus 4 pi squared, okay, on what? On t what? Squared, okay. And then here I've told you that this sign here, everything here is what? 0. But this guy here, he will multiply this one here, but this sine pi is what? 0. So everything here is 0. And you also multiply here. Here, cos pi is what? Minus 1. Minus times minus, positive. So 2 pi on what? T. Okay, so here I'm going to have what? 2 pi on what? T. Okay, then I'll come to this one, the e exponent what? 0. Okay, the lower limit, which is what? 0. So here e exponent 0 here is what? 1. So basically I'm going to have 1 over all this one. Okay, 1 over all this one. Okay, so basically I'll have and then I'll come here also. So here, if here is 0, sine 0 is what? Sine 0 is 0. Sine 0 is 0. Cos 0 is what? 1. Okay, cos 0 is 1. Okay, so now what I'll have here is that in that case, this one is going to, here sine 0 is 0. So that means that if I multiply this by this one, the whole thing will become what? 0. So I'm just going to have what? This one and this one, because cos 0 is what? 1. 1 times this one will be what? Will be what? Negative. But this negative and this negative will become what? Positive. Okay, so I'll have plus 1 over s squared plus 4 pi t squared. Okay, plus 4 pi what? T squared. Okay, and then I'm going to have what? Here it will become what? It's on t. 2 pi on what? T. Okay, so this is what I am going to have. All right, so this is what I am actually going to have. I'm sorry for my marker that it has become what? So faint. Okay, so now from here, what you can do is you can just, okay, so let me just see. Okay, so here I can have x of what? X is now equals to, I can bring a out, okay, and then apart from e, what again can I bring out? Okay, please here, let me write it here. Okay, a is already out. Okay, you see that pi is common to them, pi is common, also common here. Okay, and then t is common here, t is common here. So I can bring those ones out. Okay, so now if I bring those ones out, then I'm going to have and then I can bring 4 also out. No, 2 out. Okay, so I can bring 2 out. So 2 pi is here, 2 pi is here. So I can bring 2 pi a. So 2 pi, 2 pi a. Okay, then I can bring here t. Okay, so 2 pi on t, 2 pi on t will come out. So 2 pi on t will come out. So on t, and then a is already here. So this is what I can bring out. So now if I bring that one out, then I'll be left with this one, and then also I'll be left with this one. Okay, so this one and then this one. Okay, so basically here I'll be left with here I'll be left with this one. I can have here to be what? 1, okay, which is this one. Okay, 1 plus e exponent minus st on what? 2, okay, over, okay, over s squared, this s squared plus 4 pi on t squared. Okay, wait a minute, please. Okay, please, here it is what? Please remember, here is what? 4 pi squared. Okay, it's 4 pi squared. Okay, so that means that this place, it must also be 4 pi squared. Okay, so 4 pi squared. Okay, 4 pi squared. Okay, so here also 4 pi squared. Okay, into what? 4 pi squared. Okay, on what? T squared. So this becomes what? My Laplace transform for the what? Equation. I'm so sorry for the other ones that are a little bit what? Faint. Okay, please forgive me for those ones. Let me see if I can deepen it a little bit for you. Okay, here is like this. All right, I hope you can be able to see it now. All right, so thank you so much. See you in the next lecture. This is how you solve this question.